Okay, so type 2 ionic compounds are very similar to what we just did. I don't care if you know that they're called type 2 ionic compounds or type 1 or anything like that. That's not important to me. What's important to me is being able to figure out how to make them work. So in type 2, just like as in type 1, you've got a metal, loses electrons, becomes positive, and the metal, forms a cation. The nonmetal gains the electrons, becomes negative, and they're attracted to each other. Okay. You also typically have two capital letters. The big difference is in a type 2, the cation does not have a common charge. These are ones that they don't have a number written at the top of their column. Okay. Aluminum has a positive 3. Aluminum's always positive 3. That is its common charge. But if you look at like iron, for example, there's nothing written at the top of Fe. That's because it doesn't have a common charge. They have more than one. They tend to be transition metals, and they frequently have more than one common charge. And it is only metals that do this. Okay. So for example, iron sometimes is positive 2 and sometimes it's positive 3. Copper sometimes is something else. Positive 1, positive 2. Lead, positive 2, positive 4. So these guys, even though they are technically not in the transition metal block, they have a tendency to do this as well. So even though lead at the top of its column says positive 4, it is also sometimes positive 2. Same thing with tin. Bismuth is at a column that says negative 3. It's actually positive 3 and positive 5 sometimes. Same thing with antimony. Okay? I don't expect you to memorize them. I expect you to be able to figure them out, and I'll show you how to do that. Okay, so how do we know which charge to use? So what they've done is they've decided to use Roman numerals that will indicate the charge on the metal cation, the first thing. Okay? These are the Roman numerals you're going to have to know. If you don't remember them, make sure you recognize the difference between 4 and 6. That's about as high as you're going to have to go. Okay? You're not really going to run into anything higher than 6. So, anyhow, that's the biggest number you'll see, so they're going to use Roman numerals. So let me give you an example. The way you do this, you identify the metal and use the charge as given in the name. Remember, it's always positive because it's a metal. So iron 2, iron 3, tin 2, tin 4, lead 2, lead 4. And then you do identify the anide and use its common charge because it will have its common charge. And then all you do is drop and swap. And then simplify if possible. So I'm going to have some practice ones here. Notice how all of these have Roman numerals on them. Is there any more? Nope, that's it. Okay. So copy them down. But you're going to do the same thing you've done before. You're going to drop and swap. So Fe, that 3, positive 3. O, I looked at the top of the periodic table, it's negative 2. I'm going to drop and swap Fe2O3. Done. That 3 came from right here. Okay, chromium 3 chloride. Chromium is Cr. That 3 goes right here. Chloride is negative 1. Again, drop and swap. You get CrCl3. Okay, gold. Gold is Au, not Ag. That's silver. Au has a charge of 3. Sulfur is in the column where it has a charge of negative 2. Drop and swap. Au2S3. Okay, this one, manganese. That's different than magnesium. That is Mn. The fact that it has a 4 would also indicate that it's not magnesium. Magnesium is always 2. So 4. Selenide is in the column that has a negative 2 charge. When I drop and swap, I get Mn2Se4, but I want to reduce that to MnSe2. 2 to 4, 1 to 2. Cobalt 1 nitride, so CO1, nitrogen, negative 3, drop and swap. You get CON3. And tungsten, that's W, 4. Carbide comes from carbon, negative 4. Drop and swap, you get W4C4, but you want to reduce it to WC. And then the last one, tin. Now this is one I want to point out, especially important. Tin is Sn. Now you might look at the top of the column and go, oh yeah, it's in the 4 column. I'm telling you it's not. That 2 is telling you it's positive 2. Because tin is one of these. Even though it's not in the transition metals, sometimes it does that. and then O2 minus, drop and swap, goes to SNO. Watch for that. Tin and lead, even though they're in the column with a 4, they are not necessarily always 4. Now, naming it is a little harder. This is probably the hardest thing we're going to have in the binaries. It follows a similar procedure as type 1, except you have to include the charge. Okay? So, name the cation, so iron, chromium, manganese, tungsten, whatever they are. Name the anion by dropping the suffix and adding IDE. Okay, so that's still the same as before, but then you're going to have to do some algebra to figure out the charge on the cation and use the Roman numeral. Okay, you can just, 1 like that, okay, or 4 like that. Whatever, you don't even have to do that, but you might have to do algebra. You could do 4 like that if you'd like instead. Okay, so we're going to practice these, and I'm going to walk you through them. So first thing I'm going to do is I'm going to name the first one. So iron chloride. Now notice I gave myself a space because I recognize that iron is a transition metal, and I got to figure out what its charge is. So the way you do the algebra is you remember that the sum of the charges add to 0. So I know that chlorine is -1. I looked that up on the periodic table. There are 3 of them, okay, because of the formula. I don't know what iron is, but whatever iron is has to add up with the chlorines and add up to 0. So what I've got is I got x minus 3 equals 0. X is 3. Okay, now you might think, oh, wait a minute, I see the trick. I see it. I can undrop and swap. And I will say that is true, as long as this is a -1 charge. You can undrop and swap. Okay, that 3 came from the iron. You can do that as long as the charge on the Cl or whatever the second ion is -1. Okay, so for this one, again, tin, iodide, give myself some space, and I recognize that iodine is -1 on the periodic table. There are 2 of them, so what I have is x minus 2, because I don't know what tin is. It's not 4. Remember, tin is a weird one. Has to add up to 0. X minus 2 equals 0, therefore it's 2. This is another one that you can undrop and swap because it's a -1 charge on iodine. Okay, this one. Mn is manganese, not magnesium, oxide, and I'm going to write it underneath since I'm running out of room. Manganese is X. I add it to whatever oxygen is, -2 times 2, because there's 2 of them, has to equal 0. So this one I cannot undrop and swap because it's a charge of -2. What I end up getting is X is 4, not 2. What happened on manganese oxide is that Mn was a 4, O was a -2. When I dropped and swapped, I got Mn2O4, and they reduced it. So undropping and swapping, like we did on these 2 problems, will work as long as this is not -1, because if it's something other than -1, the odds are it's been reduced. So be aware of that. Okay, Cu2S. So it's copper, sulfide, and I don't know what copper is, X. There are 2 coppers. So 2 times X plus the charge on sulfur, -2, has to equal 0. X is therefore 1. Okay? So I'm going to erase what's on the slide so I have a little bit more room to write the next ones. All right. So CRN. So Cr is chromium. Nitrogen is nitride. Okay. I don't know what chromium is. X plus whatever the charge is on nitrogen is -3, has to equal 0. So x minus 3 equals 0. X is 3. This is one of those ones that has been reduced. You cannot undrop and swap it. Okay. Go ahead. I'm going to have you practice the next few. I think that's it. And then I'll put up the answers. I'm going to erase the ink there. Okay. So go ahead and work on these 3. Okay. And if you do it, just write the name first, the root name, add IDE, So that might not even be a bad idea. Just go through and do these first. Okay, because that's easy enough to do. So all I did was write the first name, first name, first name. Last name IDE, last name IDE, last name IDE. Now I want to figure out the charges on these guys. All right, and so I'm going to do this one up here. I don't know what nickel is, X. There are 3 nickels plus whatever phosphorus is, which is -3 on the chart, equals 0. So 3x minus 3 equals 0, x equals 1. For this one, I have the same kind of situation, except it's 3 times the nickel plus 2 times the -3, s equals 0. So I have 3x minus 6 equals 0. X is therefore 2. And then for the last one, I don't know what bismuth is. I know what column it's in. It's not a transition metal, but it behaves like one, so you have to use a Roman numeral. I have X for the bismuth. There are 2 of them. Plus 3 times oxygen, which is -2, equals 0. So I got 2x minus 6 equals 0. X is therefore 3. Okay, so these are harder. Take your time. Okay, do the algebra if you have to. But don't get in the habit of automatically just saying, oh yeah, look at that, 2, boom, manganese 2 oxide, because that's not correct. Okay, you have to think about it a little bit.